All right, let's get right into it. If you're a senior dev or an architect, you've seen the hype around AI coding. And you know the reality can be, well, a little frustrating. We're not talking about autocomplete here. We're talking about the big dream, an AI that can take a complex document and build an entire software project from scratch. Today, we're going to break down a framework called DeepCode, which gives us a seriously practical blueprint for making that dream a reality. So here's the vision, right? An autonomous AI engineer. You could hand it a 50-page design doc, a dense research paper, and say, go build this. And it does. It builds the whole thing, an executable working application. It's the ultimate holy grail for AI agents. But as anyone who's ever tried to get an LLM to build something bigger than a single script knows, there's a huge glaring problem standing right in the way. And that problem is something you've definitely felt. It's this fundamental mismatch. On one hand, you have the real world, a client's requirements, a research paper, which is just an explosion of information. Details are scattered all over the place. On the other hand, you have the tool you're using, the LLM, which has this tiny, narrow little doorway to see the world, its context window. And this hourglass visualizes it perfectly. It is exactly like trying to pour the entire ocean of project information through a tiny little straw. All this rich, complex, critical data gets jammed up in this context bottleneck. The LLM simply can't see the whole picture at once. And look, this isn't just some minor inconvenience. This is what causes catastrophic, project-killing failures in the code it tries to write. And I bet these failures sound painfully familiar. First, specification preservation goes out the window. Remember that one critical detail buried on page 37 of the spec? Yeah, the AI forgot about it the second it started coding. Second, you lose global consistency. The function you defined in file A, it's being called completely wrong in file B, because the AI has no memory of what it just did. Third, you get underspecified design, which means the AI has to guess. And oh boy, does it guess wrong. It'll just pick a random library or an outdated pattern. And finally, the most soul-crushing one, zero executable faithfulness. The code looks like it should work. It's plausible, but try to run it, it's a complete house of cards that falls apart at the first compiler error. So the answer can't just be, let's make the context window bigger. That's just using a slightly wider straw. It doesn't solve the fundamental problem. The real paradigm shift, and this is the core idea behind DeepCode, is to stop thinking about more context and start thinking about smarter context. It's about acting less like someone just stuffing tokens into a machine and more like a software architect who intelligently manages the flow of information. This quote from the paper, this is the new golden rule. It's not about brute forcing more data in. It's about being strategic. You have to structure, route, and compress information. The goal is to maximize the signal, the stuff that actually matters, while cutting out all the noise. This is exactly how a great architect thinks, and it's the engine that powers DeepCode. So let's look at the toolkit it uses. So how does DeepCode actually do this? Well, it puts this strategy into practice with 4 core components, or pillars. You can think of these as the 4 essential tools in our new AI Architects Toolkit. Each one is specifically designed to tackle one of those failures we just talked about. Pillar number 1 is source compression. A better way to think of it is the master blueprint. Imagine a client comes to you with a bunch of vague ideas, notes on napkins, random emails. What's the first thing you do? You don't start laying bricks. You distill all that chaos into a single, structured, precise construction blueprint. DeepCode does exactly that. It takes a messy source document and transforms it into a clean, machine-readable plan before writing a single line of code. And you can see that process right here. It's taking all that unstructured, messy stuff and compressing it down into a high-signal blueprint. This blueprint defines everything: the file structure, the components, their interfaces, even the plan for how to verify the code later. This becomes the single source of truth for the entire project. Okay, pillar number 2, structured indexing. I like to call this the living project map. Think about it. As a building is going up, an architect doesn't reread the entire 100-page blueprint every single time a new window is installed. Of course not. They keep a high-level model, a map of the project's current state, in their head. That's what DeepCode does. It maintains a compressed summary of the codebase as it's being built so that every new piece fits perfectly without having to cram all the existing code back into that tiny context window. This is done with something the paper calls stateful memory. It's pretty clever. Every time a new file is created, it gets summarized into its essential parts. What does it do? What's its public API? What are its dependencies? That summary becomes a little node on the project map, giving the AI just enough context to maintain that global consistency without getting overloaded. Next up, pillar 3 is knowledge injection, or as I call it, the expert's bookshelf. You know how sometimes the blueprint will say something generic like, implement a secure login, but it doesn't specify the exact hashing algorithm? A good human architect grabs an engineering manual to look up the current best practice. DeepCode does the same thing. When the blueprint is a little vague, it intelligently pulls in standard patterns from a knowledge base of high-quality code. The tech behind this is Retrieval Augmented Generation, RAG. You've probably heard of it. It's essentially like giving the AI a technical library it can search through to find the best way to implement something common, like a REST API endpoint or a data processing function. This stops the AI from just making stuff up and, getting it wrong. And finally, pillar number 4, and this one is a real game changer: error correction. Think of it as automated quality control. A good architect doesn't just hand over the blueprint and walk away. They do site inspections. DeepCode creates this automated feedback loop. It doesn't just spit out code and hope for the best. It actively tries to compile it and run it. And when an error pops up, because it always will, a syntax error, a failed test, whatever, the system doesn't just give up. It reads the error message, figures out what went wrong, and then feeds that error right back to the LLM with a simple command: fix this. It's a self-healing, closed-loop system that actually debugs itself. This is how you get code that isn't just plausible, but actually works. So that's the theory, a really elegant 4-part system for creating an AI architect. It sounds great on paper, right? But the million-dollar question is, does it actually work? And more importantly, what can you learn from this to get better results with AI today? Okay, prepare for the big reveal, because this is wild. The researchers tested this on a benchmark called PaperBench, where the AI has to replicate code from machine learning papers, a super complex task. Existing commercial AI agents, they solve it about 50% of the time. A team of actual human experts, PhDs from top universities, they managed a score of 72.4%. DeepCode, using this 4-pillar method, scored 75.9%. Just let that sink in for a second. This system isn't just better than other AIs. On this really hard task, it actually outperformed top-tier human experts. The methodology is legit. And this is the best part. You can start using these exact same principles in your work today. Number 1, blueprint first. Before you even think about writing a prompt, sketch out the file structure and the key functions. Give the AI a plan. Number 2, use summaries. Don't just paste a 1,000-line file for context. Write a 5-line summary of what it does and what it exports. Way more effective. 3, provide examples. Don't ask the AI to invent a new way to handle logging. Give it a good example from your existing codebase and tell it to follow that pattern. And 4, iterate with feedback. Stop treating the AI like an oracle. Treat it like a junior dev. Take its code, run it, and when it breaks, copy the error message and tell it to fix its own bug. See, when you start working this way, your role naturally begins to shift. You'll find yourself spending way less time writing boilerplate code and way more time designing the system, creating those blueprints, and managing the overall structure. You become the architect, guiding a very, very fast AI builder. And whoa, I know that was a ton of information, but the key thing to remember is that this isn't some abstract theory for a distant future. These are practical principles you can use right now to get massively better results from the AI tools you're already using, putting you in the driver's seat to shape what comes next. Hey, if you enjoyed this deep dive and you want more of these aha moments that give you a real edge at work, do yourself a favor and subscribe to VibeDoc. It's just one click, and let's just say mastering concepts like this, well, it could make your next performance review a lot more fun. Just saying. So, I'll leave you with this one final thought. The conversation is changing. It's no longer about can an AI write a function? We know the answer is yes. The real career-defining question that we all need to start asking is, can you architect the system that guides the AI? Thanks for tuning in.